Today, we're going to discuss points of inflection and concavity. Okay, let's take a graph of a function that looks like this. The graph is concave up on this side and then concave down on this side. And then the point at which the curvature changes from concave up to concave down, that point here is a special point. It's called a point of inflection, POI. We're going to figure out where the points of inflections are using calculus. Okay, a graph is concave up wherever in any interval in which the second derivative is positive. If the second derivative is negative, then the graph is concave down. And then the point of inflection is the point at which two things have to happen. The second derivative must be equal to 0, and the sign of the second derivative must change from plus to minus or minus to plus. So C, f of C, is a point of inflection if and only if f double prime of C is equal to 0, and also f double prime of C changes sign. This is very important. Changes sign as x crosses C. So it has to change from plus to minus or minus to plus in order for this to be a point of inflection. It's the point at which the curve changes from this concave up to this concave down. Let's do some examples. The first example is f of x equals 4x cubed minus 6x plus 3. The first derivative of this, we need the second derivative for the points of inflection. First derivative is 12x squared minus 6. One more. Second derivative is 24x. Okay, first we need to set the second derivative equal to 0. So 24x equals 0 means x equals 0. So x equals 0 is a point of interest. We need to figure out, does the second derivative change sign or not as x crosses 0. So we're going to do this. X. Okay. We need to pick a test point to the left of x equals 0 and the test point to the right of x equals 0. So what I'm going to do, I'll pick x equals minus 1 to the left and then substitute minus 1 in the second derivative here. So the sign of f double prime would be f double prime is 24 times x. 24 times the number we picked. So this is negative. And on the right side, I could have picked a small number, but I just want to pick 10, x equals 10. So the second derivative is 24 times 10, which is positive. I could have picked 1. You can pick any number. You can pick square root of e, if you like, or square root of pi, or anything you want. Just make sure you pick a point to the left and one to the right. The second derivative was negative. It switched to a positive, so it changed sign. Now remember, the second derivative must be equal to 0, and it must change sign in order for that point to be a POI. So C, which is 0, f of 0 is a POI. We can calculate f of 0 by substituting 0 in the original function. Here's the original function. So if you put 0 here, you end up with 4 times 0 minus 6 times 0 plus 3, which is 3. So f of 0 is 3. So the point of inflection would be 0, 3. 0, 3 is a POI. As far as I'm concerned, if you leave it like this, it's fine. If you write 0, f of 0, for my students, you can leave it like this. You don't have to calculate 3. So 0, f of 0 is a POI. 202. Let's find if there are any points of inflection of the graph of this function. X cubed minus 3x squared minus 10. The derivative of this function is 3x squared minus 6x. Second derivative would be 6x minus 6. And we need to set this equal to 0. So 6x minus 6 equals 0. 6 x minus 1 equals 0, that means x equals 1. So x equals 1 is a special point, okay? 1 minus infinity plus infinity. We need to pick a test point to the left and one to the right. The easiest test point to pick anywhere is x equals 0. It's to the left. So let us calculate the second derivative for x equals 0. Second derivative is f double prime, which is 6 times 0 minus 6. This would be negative 6, and that's negative. Let's pick a test point to the right. Okay, this time I'm going to pick x equals 2. X equals 2 for my test point. So put 2 in the second derivative, 6 times 2 minus 6, which is 12 minus 6, and that's 6, that's positive. So yes, it changed signs. So therefore, this point here, 1, f of 1, is indeed a POI, point of inflection. We're going to do a third example. 3. F of x equals 2x to the 4th minus 3x plus 12. The first derivative is 8x cubed minus 3. Second derivative is 3 times 8, which is 24x squared. And we need to set this equal to 0. 24x squared equals 0 means x equals 0. So x equals 0 is a special point. Let's do it over here. Minus infinity plus infinity. I'm going to take a test point to the left. Okay, let's pick x equals negative 1 again. Substitute negative 1 in the derivative, second derivative, 24 times negative 1 squared, that's a positive 24. Pick a test point to the right, I'll pick plus 1 this time. 24 times plus 1 squared is also positive. This time, the second derivative did not change signs. So therefore, 0, f of 0 is not a POI. So we'll just say there is no POI. The point we got, the special point x equals 0, is not a point of inflection because the second derivative did not change signs. And this completes the lecture on points of inflection.